Hello all, I am Harsha Rahul and I'll be giving the starting of the presentation for the Plag Detector for Team-204 and my teammates will be following. So the first and the foremost, the system functionality. And did we actually finish all the basic requirements? Yes, we did finish all the basic requirements. And also most of the stretch goals were implemented by us. For each sprint, we added the functionalities and as the backlogs, and we as a team we were able to finish them. So as far as the basic functionality goes, the assignments. So the process is like where a student can register himself, uh, go to the course, to his assignments, upload his assignment either as a GitHub link, or as a zip folder of his project. So he can have multiple submissions for the same assignment, but he cannot remove anything. Once he actually submits it, the system internally takes it for stage 2, where it automatically runs a detection algorithm, which is being powered by like jplag libraries. And here the assignment can be in Python, Java, C, and or C sharp. So it can detect plagiarism in all four languages. And the student assignment is compared against every other student's submission across semesters and also years. So once the engine detects any plagiarism, it will actually notify the student, the professor in charge of the course, and the entire mail chain gets notified. And so the visualization, how it happens is a professor has three approaches: either actually log into his dashboard, see the notifications, and redirect to the results page, or through email, where a link is given to him and he can go directly to the results page. And once the main page where he can actually see the thing is this graph page, where the entire graph of the students for that particular assignment is shown. The edges actually represent the percentage of plagiarism between the students. The nodes are obviously the students. And to dig further, you can actually click on a particular edge, and the relation between the two students, their names, their files which have been copied, and also further options to take further action can be taken. So the completion, yes, all the functions, basic functionalities, and also the stretch goals have been successfully completed, are stable, and also been uploaded in AWS. We really feel the system is very user friendly, and it has a real time use for deployment in anywhere, because it does not require much interaction from the user, and it is scalable and also deployed in AWS. So the pie chart actually shows the backlogs that we have actually added, as we have added all the functionalities at backlogs, and we have solved them in all the sprints, and we have completed the thing successfully. And the next part will be taken by my friend.
My name is Krish and I will take you along this section of job quality. Quality was the most focused part all through this project. Now to maintain this quality, we followed certain key points which are as follows. We used three layers: controller, service, and the database layer, which is the DAO. Now to connect any two layers, we use auto-wired, which is the Spring Boot annotation. This annotation helped us to reduce our connection code, which could have brought many bugs with it. Secondly, we used a row mapper class to map the data from our tables to our models and get the list of rows. And at last, we maintained the modularity of our code. Modularity was quite important since certain functions could be used many places in our program. And apart from these 3 points, we also had try catch in our codes, in which we handled certain exceptions and performed accordingly. And also all through this work we had certain bugs which we were able to solve immediately, and at last we were able to bring the bug count to 0. There were certain code smells which come as we build the code, so we were also able to bring the code smells down to a very less number at the end. Also, here's a graph which shows you how we got the bugs and how we solved the bugs. As the graph moves up, you can see that we had some bugs, and as it comes down, the bugs was solved. So as soon as the bugs came, we were able to sit down and solve the bugs immediately. So that was the major quality point. And at last we were able to tackle the quality for each and every sprint, and we were finally able to bring the quality grade to A, as can be seen in our sonar cube reports. Yeah, so now that's it for the job quality. Let's move to the next section.
My name is Varun Nandu, and I'm going to speak about process and teamwork. So, in process and teamwork, we basically had individual work assignments given to each other based on our strengths, and we integrated our individual parts at the end of each sprint or each phase into for the entire system. We also, it can be seen on GitHub repo that we divided our project into three phases: phase A, phase B, phase C. Phase A consisted of requirements gathering, creation of user wireframes, use cases. Phase B consisted of making UML class diagrams and creating skeleton interfaces of classes. Then phase C consisted of implementation, testing, and debugging of the system. The phase C was most difficult phase, and it was divided into three parts: setting up of development environment, and basic comparison between two files was achieved in sprint one. Second sprint consisted of creating various entities for the project like assignment, semester, user, courses, submissions, and snapshots. Scaling for different kinds of users and multiple users was also achieved during this time. It also consisted of implementing more advanced comparison strategies across files. The third sprint consisted of basic CRUD operations on each entity mentioned earlier. We also redesigned UI to create a nicer UX experience. We did rigorous testing and debugging of the system. We made it stable and deployable after each sprint, as my friend Krish said in the earlier part of the video, on based on the graph. For automation, building, testing, and processes, we used various technologies. For example, we used Jenkins for continuous integration and deployment to AWS, and the integration only passed when the quality and testing gates of the Sonar Cube passed. Then only our code was merged into our main code base in master on GitHub, and then it was deployed to AWS. We used Jira for maintaining issues and bug tracking and fixing. We also used Slack and emails for communication. There are two basic challenges that we faced. First was deploying JPlag libraries to AWS. We found some method as a team to work on it, and finally we found an approach that worked. The other challenge we faced was integration, and integration was achieved after careful consideration.
Hi, I'm Ming. I'm member in Team-204, and now I will talk something about technology transfer. And just like what our teammate already said, we have to do lots of things in your project. You can see, I think all projects already been to hand out to a client because we already fixed the bugs and already changed the UIs, and we do our best to use different technologies and to make the user experience really streamlined. And I think the user will prefer to use our system. And this system also can accept different kinds of fields, just like the folders, the Python fields, the Java fields. And also you can just give us your GitHub links and also can compare the whole things. And our system will store the historical results of the different assumptions by the students. And maybe he already submitted lots of times, but we will compare each and for the different semesters. And although I think our system is very good enough, but we still have something to fix and update it because the project always need to fit the requirements of the users. So the users of our system is the student and professors. We want to make our system more accurate and to better find the plagiarism. So probably we can use some machine learning technologies just like LSTM and to get a better result. And also we can have some another algorithm, just like longest consecutive algorithm, or maybe we can create a SD tree, and also apply some digital algorithm, and we can combine the whole algorithm and to make a weighted polynomial function. I think there will be more accurate and help us to detect the plagiarism. So although there are a lot of things that we want to say, but I think we already done a lot of things, and I hope we'll do it better. That's all.